We live in a world that demands precision. From the smartphones in our pockets to the spacecraft exploring the cosmos, the need for intricate and accurate manufacturing has never been greater. As technology advances, so too do the tools and techniques we use to shape our world. Among these innovations, electrical discharge machining, or EDM, spark erosion stands out as a testament to our pursuit of precision. EDM has revolutionized manufacturing. It allows us to create complex shapes and intricate designs with incredible accuracy. This technology has become indispensable in various industries, pushing the boundaries of what's possible. Imagine harnessing the power of thousands of tiny lightning bolts to sculpt metal with unparalleled precision. That's the essence of EDM Spark Erosion. This non-traditional machining process utilizes controlled electrical discharges to remove material from a workpiece. Unlike conventional methods that rely on mechanical force, EDM harnesses the energy of sparks to erode material with incredible accuracy. The process occurs in a dielectric fluid, usually deionized water or oil, which acts as both a conductor and a coolant. At the heart of the EDM process lies a seemingly simple setup. A workpiece, the material being shaped, is submerged in a dielectric fluid. An electrode, typically made of copper or graphite, is positioned near the workpiece. A precisely controlled electrical voltage is applied between the electrode and the workpiece. As the gap between them closes, the dielectric fluid breaks down. This breakdown creates a channel for a spark to jump across the gap. This spark, a miniature bolt of lightning, carries immense energy. It vaporizes a tiny portion of the workpiece material. This process repeats thousands of times per second. Traditional machining methods, while effective for many applications, often fall short when it comes to intricate designs and hard materials. EDM Spark Erosion, however, excels in these areas. Because it doesn't rely on mechanical force, EDM can machine extremely hard materials with ease. The non-contact nature of the process also eliminates the risk of mechanical stress or distortion, making it ideal for delicate parts. Whether it's creating complex cavities in aerospace components or intricate cooling channels in medical devices, EDM offers a level of precision and flexibility unmatched by traditional methods. Section 5. Graphite, the unsung hero of EDM. While the EDM process itself is fascinating, the materials involved are equally important. Graphite, a form of carbon, plays a crucial role as an electrode material in EDM. Graphite's unique properties make it ideal for this task. It possesses excellent electrical conductivity, ensuring efficient spark generation. It also has a very high melting point, allowing it to withstand the intense heat generated during the erosion process. Furthermore, graphite can be easily machined into complex shapes, enabling the creation of electrodes that perfectly match the desired workpiece geometry. Section 6. EDM Applications, Shaping Industries, Igniting Progress. The precision and versatility of EDM Spark Erosion have led to its widespread adoption across a multitude of industries. In aerospace, EDM is used to create intricate components for jet engines, turbine blades, and fuel injection systems. The medical field relies on EDM to manufacture implantable devices, surgical instruments, and dental tools with exceptional accuracy. The automotive industry utilizes EDM for producing complex molds and dies for manufacturing engine parts, transmission components, and body panels. From the smallest micro-components to large-scale industrial molds, EDM is shaping the world around us. Section 7. Eroding Boundaries, the Future of EDM Spark Erosion. As technology continues to advance, so too does the potential of EDM spark erosion. Researchers and engineers are constantly pushing the boundaries of this technology, exploring new materials, refining processes, and developing innovative applications. One exciting area of development is micro-EDM. This technique utilizes extremely small electrodes to create intricate micro-features on a scale of just a few micrometers. Another promising avenue is the integration of EDM with additive manufacturing, also known as 3D printing. This hybrid approach allows for the creation of complex geometries that would be impossible to achieve using either technology alone. Section 8. Erodex, pioneering precision in EDM for 50 years. In the world of EDM, Erodex stands out as a leader in providing premium graphite solutions. With a legacy spanning half a century, Erodex has been at the forefront of this technological revolution. Erodex understands that precision is paramount in EDM. They specialize in producing high-quality graphite electrodes tailored to the specific needs of their clients. Their expertise extends beyond just materials. Erodex offers a comprehensive range of services, from technical consulting and design support to precision machining and EDM wire supply. They are committed to innovation, constantly investing in research and development to push the boundaries of EDM technology. Section 9. Conclusion: a spark that ignites the future. EDM Spark Erosion represents a triumph of human ingenuity. It's a testament to our relentless pursuit of precision and our desire to shape the world around us with ever-increasing accuracy. As technology advances and new applications emerge, EDM will continue to play a pivotal role in shaping the future of manufacturing. With companies like Erodex leading the way, we can look forward to a future where the only limit to what we can create is our imagination.